Have you ever thought about learning to code but felt overwhelmed by the options, jargon, and seemingly endless tutorials? Or maybe you tried it, but it felt like drinking from a fire hose and you gave up. Here's the truth, coding isn't as hard as people make it out, if you approach it the right way. In this video, I'm going to walk through how I would learn to code if I was going to start it today. There's no fluff, no upsells or gatekeeping, just a simple, clear roadmap to help you get started and make real progress.
Why coding matters.
Coding is a superpower of our time. It's the invisible engine behind the apps on your phone, the AI that's reshaping how businesses operate, and the blockchain technology that's creating a decentralized future. And the best part, coding isn't reserved for Silicon Valley elites or people with advanced math degrees. If you've got a laptop and some time and a bit of curiosity, you can learn to code. Geez, if I can do it, then you should be fine. We aren't talking about trying to build a Death Star out of Lego here. Coding is about solving problems, building tools, and creating value, not memorizing algorithms or writing lines of mathematical formulas. By the end of this video, you'll have a clear blueprint for how to get started coding in the easiest and most practical way possible. The right programming language for you. The first hurdle every beginner faces is choosing a programming language. The choice depends entirely on your goals. If you want to build a website, then JavaScript is your best bet. It's one of the most versatile and widely used programming languages in the world. And JavaScript isn't just for websites and front-end development. It can be used on the server side as well with frameworks like Node.js and Dino, meaning you can probably build whatever monstrosity your imagination can come up with using a single language. This makes it, in my opinion, the best first language for most people, including kids. If your interests lie in AI, data science, or automation, then there's an argument that you should learn Python instead. Python is famous for its simplicity and readability, making it an excellent choice for beginners. Python is incredibly powerful and it's widely used by data scientists and machine learning engineers. It excels at creating quick scripts to automate tasks or to crunch large data sets on a local system. For those interested in performance and system-level programming, Rust is an excellent option. Rust is a fast, safe, modern language that's perfect for building high-performance applications like gaming engines or blockchain infrastructure. It's a bit more challenging to learn, but if you can master it, then you'll get a deeper working knowledge of how systems and software work behind the lines of code. Lastly, if you're fascinated by blockchain like I am, and Web3 and decentralized technology, then you should look into Solidity or Rust. Solidity is the main programming language for Ethereum and EVM compatible smart contracts, while Rust offers an alternative for networks like Stellar, Solana, and Polkadot. Even if you do want to specialize in something like smart contract development, I think there's still a benefit to learning a more general language like JavaScript first. Often I'll get called in to help front-end teams integrate contracts into their code, and you'll end up working with JavaScript a lot whether you want to or not. The key takeaway is this: don't overthink your choice of language. Start with one that aligns with your goals, and you can always learn others as you grow. And don't be daunted by the feeling that you need to learn multiple programming language. It's not like learning Mandarin once you've picked up French. Programming languages all essentially do the same thing, and learning another one is just a case of figuring out a slightly different syntax, the style, and the nuances of a new language.
The developer toolkit.
Once you've chosen a programming language, the next step is to set up your developer toolkit, your tools that can make or break your coding experience. The first tool you'll need is a reliable text editor. I recommend going with Visual Studio Code, VS Code, as it's commonly known. It's free, it's made by Microsoft, it's highly customizable and packed with features that make coding easier. You can install third-party extensions from a public library that provides syntax highlighting, debugging tools, and even real-time collaboration features. In addition to a text editor, you'll also need to learn version control, which is essential for tracking changes in your code and collaborating with others. GitHub Desktop is a great way to get started with this. It provides a user-friendly interface for managing your code repositories, rolling back changes, and working with teammates. We'll get into this more later. Another must-have skill is understanding the terminal or the command line. While it might seem intimidating at first, mastering basic terminal commands can dramatically improve your productivity. Commands like cd to change directory, ls to list the files in a directory, or mkdir to make a new directory are fundamental. And the terminal also gives you access to tools that are impossible to use through a graphical interface, including those that you make yourself. Finally, consider taking advantage of AI-powered tools to accelerate your learning. Two most widely used ones are Copilot and Cursor. These can write code for you, they can help you troubleshoot errors, and even teach you new coding techniques as you type. It's like having a coding mentor by your side 24/7.
The building blocks.
At the core of every programming language are a few fundamental concepts. Variables are one of these building blocks. Think of them as containers where you can store data. For example, if you're working in Python, you might write x equals 10 to store the number 10 in a variable called x. Variables let your programs hold information and use it dynamically. Loops are another cornerstone of programming. They allow you to automate repetitive tasks. For example, if you want to print a message 100 times, you can use a loop to do it in just a few lines of code rather than writing out 100 times. Whether you're using a for loop to iterate over a range or a while loop that continues until a condition is met, loops are a powerful tool in your arsenal. And these conditions are equally important. These are the decision makers in your program, with statements like, if something is true, do this, else do this. You can make your program respond to different situations. For example, you could write a program that checks the weather and then decides whether to display, bring an umbrella, or we should emigrate somewhere warm. These building blocks might seem simple, but they are the foundation of everything you'll create as a programmer. Once you've mastered them, you'll be ready to tackle more and more complex code patterns.
Data types and storage.
Understanding how computers store and manage data is critical to becoming a proficient coder. Data is everywhere and it comes in many forms. For instance, text is stored as data type called a string, while whole numbers are stored as integers. In Python and JavaScript, you don't need to explicitly declare data types, but in languages like Rust, you'll need to specify them. This is called strong typing. While it might seem tedious at first, it ensures your programs run more efficiently and with fewer bugs. Persistent storage is another key concept. This is how your programs save data for later use. For example, you might write data to a file on your computer's hard drive or use local storage in a browser to store information that persists between sessions. Understanding these techniques will allow you to create applications with real-world functionality, such as saving user preferences or tracking progress.
Debugging like a pro.
No matter how carefully you write your code, bugs are inevitable. Debugging is a skill you'll need to master, and it's where most of your learning will happen. One of the best tools for debugging is ChatGPT. If you encounter an error, you can paste the error message into ChatGPT, maybe with a code snippet as well. It'll often help you identify the problem and suggest a solution. Unit testing is another invaluable technique. By writing small, focused tests for each part of the program, you can ensure that everything works as expected before moving on. When you're working at the cutting edge of technology, debugging and testing become a significant part of your workflow. Embrace it. It's a sign that you're pushing boundaries and doing work that matters.
GitHub and package managers.
Open source is the backbone of modern programming, and GitHub is its epicenter. Learning how to use Git isn't just about version control, it's about contributing to a global community of developers who are building the future. You can use GitHub Desktop, which we discussed earlier, to manage your repositories, collaborate with others, and back up your projects. In GitHub, we can add a new repository, then let's create a file in that repository, then we commit the changes before pushing them to a remote data store at github.com. If someone else wants to contribute, they can make changes to that code, submit a pull request, which you can approve or deny on your repository. This push-pull mechanism in Git is like sending and receiving code. When you push, you take your local changes and send them to a central remote master repository. It's like mailing out your latest draft to everyone that's working on the code. Then when you pull, you fetch the latest changes from the remote repository and merge them into your local copy. This keeps everyone's code synchronized, ensuring that collaboration is seamless and no one's working on outdated files. Package managers are another essential tool. They allow you to quickly add functionality to your projects without having to reinvent the wheel. For example, npm for JavaScript and pip for Python let you install libraries and frameworks with a single command. This means you can build your code on top of other people's code using the latest functions and logic without needing to write everything from scratch. Need to write out to a CSV file or a PDF? There'll be a library for that. Need to connect to OpenAI's API to build your own version of Skynet? There's a library for that too. This modular approach means that we can create mashups of different functions and APIs that are available to us, often for free, to build out interesting programs.
Learning by building.
The best way to learn anything, in my opinion, is to enjoy the process. The journey as you level up is often more rewarding than reaching any predetermined destination. For that reason, I'd suggest coming up with an idea for something that you want to build, and then just trying to do it. That might be a website, an app, a Hello World Node.js script, or whatever you want. If it's your first program, it's probably not going to work first time, and the final code probably won't impress anyone. But it's an achievement, and you'll learn so much along the way that it will give you a base knowledge for writing your next program, and the one after that. The important thing is just to get started, embrace the challenge, And if things go wrong and the fan, just ask ChatGPT to help out. Learning to code is one of the most rewarding journeys you can take on. It's not just about writing programs, it's about solving problems and implementing creative solutions, and it can be a really enjoyable process. With the blueprint that I've shared today, you have everything you need to get started. Remember, the key is to stay curious, experiment fearlessly, and learn from every mistake. I hope this video has helped. If there's anything I've missed or I can do better, then let me know in the comments. I'd love to hear what you're working on or what topics you'd like me to cover next. If you want to stay up to date with emerging technology, then hit that like button to train the algorithm, subscribe to the channel, and thank you for watching.